Yes, good morning, one and all. As far as the operational research subject has been considered, in the previous classes have been discussed very much detailedly regarding the genetic algorithm method and some iterative process of methods and optimization technique that is being utilized for solving the different typical kind of problems related to the production and distribution channel related. And in the present day's class will be proceeding towards the sequencing or technology that is being utilized in the case of this production or industrial basis, which relates to both production and storage transportation. As the term sequence referred, that is an order in which the jobs are processed. The sequence problems when arises concerned with the situations, it is a choice in which the number of jobs can be performed simultaneously, or different types of works can be performed simultaneously. The sequence problems involve the following parameters, which plays a crucial role for solving the almost all the typical kind of situations. Initially, implementation of or incorporation of jobs in a manufacturing plant. At the periodical range will be utilizing this sequencing technology as per the marks criteria or as per the merit oriented criteria should be followed, along with the proofs that need to be submitted at the time of recruitment, and even different segment oriented jobs or staffing will be done at various levels depending upon the performance criteria. Next, moving on to the second sequence related, that aircraft which is waiting for landing and clearance, that is almost if any of the plane in the airport already existing in the runway, it has to be cleared before and for that particular purpose, ideally the plane will be wandering in between or nearby the airport, and after clearance of the runway, then the signal or activation signal will be given to the plane to be landed. At that particular time, the sequence plays a major important role. And maintenance scheduling in a factory from one plant to the another plant, or else from one godown to the another godown, or one warehouse to the another warehouse, in such a way. Programs to be run on a computer, that is also in a sequence manner, even in our mobile phones also as well. When you have been taken this Play Store app, upon clicking that, update all the softwares that are being installed in the mobile, it will follow the sequence priority as per the given input to the system, that based upon the size of that particular application, least MB containing files will be updated first, and later on will be moving on for the highest MB containing apps. So as per the criteria that has been set within the hardware, or else the major controlling software, either the computer or else the any of the electronic media will be operating. Next, from customers and bank and as so on. There will be follow first come first serve. There is an quotation that first serve first gain. Hence, who approaches the bank initially, they will be completed their work with the workers existing in the bank, and later on the second person. And for this particular examples that have been even or visualized in the case of sequence, there are some terms and conditions used. There's jobs. Moving on to the jobs, first one. Any of the jobs or any of the things or customers or different kinds of orders, these are the primary stimulus for sequencing. There should be a certain number of jobs. For example, they're having 10 or 15 jobs are to be processed or sequenced. For that, nominally we'll be getting 1:10 ratio related, that is, instead of providing 10, we'll be getting 100 different applications of similar qualification. And based upon that, we'll be filtering and selecting the suitable candidates for those 10 different jobs. And for that, there will be a sequence, and that sequence involves the criteria to be followed for recruiting the persons in the prescribed job. Next one, number of machines. So basically the machine is characterized by a certain processing capabilities through which a particular job must pass before it completed in the workshop. And it's not a only device that will performing the work, and instead of performing that work, the human power is required to monitor the machineries for completing the task in a preferred manner or as per the given designs. Hence, manual power, hence we'll be calling this as an dynamic numerical control machineries, that is involve equal share of involving both the manual power as well as the computer power, that is the software sectors. For example, we are containing the number of machines. For example, it is in K to be processed and used for processing the different jobs. So almost all these machineries helps us to capture the overall data of particular resumes or curriculum vitae that we are having as an from the applicants, and it will filters as per the criteria given in the form of program to the system. If any of the profile doesn't suits with respect to the criteria given, then automatically it will be getting rejected. That is the machinery utilization in the case of this recruitment. Next one, moving on this processing time. So how much time will be taken for processing each and every kind of the task? And here scheduling plays a major important role. So scheduling in the sense, the forecasting task needs to be performed within a particular time period that will be getting assigned or stored within the computer by giving the time, and as per that the intimation will be getting given to the operator 10 to 15 minutes before that the particular task has been scheduled in so and so time that need to be allocated by you in such a way. And the previously the industrial field, a siren in the form of a siren, the shift timings will be getting characterized, but present days due to the updation, each and every individual candidate will get the SMS to their mobile or else the direct operational call through the net service. that the shift time is being reaching to you. And even one minimal example, and even I have been scheduled this class time for you at 11 a.m., and that message I have been kept to you morning 9 itself, at morning 9 itself. So I have been scheduled, present scheduling, and I'll be getting the message that before 15 minutes that the class is about to start. So in such a way, the processing plays a major role. And in some of the cases, the scheduling is uncertain and leads to very much complex in cases in a manufacturing, particularly in the manufacturing areas. Total elapsed time is the time between starting the first job and completing the last job, and in between the n number of jobs or the scheduled jobs will be performed. Ideal time, the times that is remained by keeping the entire system or machinery in an ideal mode. So it indicates without any performance, the machinery will be in an ideal mode. Technological order. So different jobs may have different technological orders. Nothing but the operational parameters will be very much differ. For example, if you been considered our workshop, one it is an one of the machinery will be working with respect to the lathe machine, and one other one is drilling machine, one other one is milling machine. So each and every machinery will be having different dimensional accuracies and different tools required to operate on that machineries, and different persons need to be engaged for operating that machineries. So likewise, there will be an technological order, and even when we are giving in the case of this computer numerical control technology method also, the CNC programming will be fed to the system which requires for completing the jobs without any involvement of the human beings. There is automatical way. If there is any malfunctioning happening, then the requirement of this human power is necessary for correcting the obtained or what is lagging for operating the machinery. Here is the statistics, that is starting of the program, and at the machinery 1 and machinery 2, machinery 3, and next machinery 4, and finally the finishing process. So here we are considering this machinery 1, and from the starting the input material will be fed to the system, and here considering this is an one section 1, section 2, section 3 and 4. So for in one of the, for each and every type of the workpiece, different processes need to be commenced. So first process may be of drilling, second process may be of milling work, third process may be of drilling work, again drilling work, and next for the fourth one it is an reaming process, and after reaming process it will be moving on to the finishing strategy. And at that finishing strategy, the inspection process will be considered, and that inspection, based upon that inspection, the packing will be taken place and moved on to the warehouse for storage, and based upon that preference it will be transported to different or shipped to different areas as per the order basis. So this is the criteria that is are followed, and for this the sequencing is required. So first one, after completing of drilling only, the milling process need to be commenced, and after milling again the internal drilling process need to be performed, and later on the reaming process for the drilling, and finally the task has been completed for that particular piece. And vice versa, if another material has been entering into the first device, the material which is completed in the first phase of this M1 will be traveling to the M2. So this is a cyclic process. At each and every phase, one of the material will be commencing its activity. So here, while performing the reaming on one of the object, simultaneously here drilling will be performed. Simultaneously here milling will be performed on another object. So within the one particular strategy, here four different tasks are being performed simultaneously. That is the main motto. So for that we will be seeing the different types of sequencing problems existing for us. First one, problems with n jobs through one machinery. As we have discussed now, only we are having one machinery. On that machine itself we have to perform n different types of jobs, nothing but milling, drilling, reaming, overall finishing, etc. The overall objects need to be performed by only that particular single machine by changing the tool bits. And the second case, it is problems with the n jobs through two machineries. So containing two machineries, and we are having four different jobs, that is milling, drilling, reaming, and next to the finishing process. And two different jobs will be performed in one machinery. Later on, it will be shifted to the another machinery for commencement of another two jobs, and vice versa. N jobs need to be performed on three machineries, and this n will be getting varied. Maybe having we have discussed during the four different kinds of jobs, but it may be varied even more, maybe involving of 7 jobs, 8 jobs, 10, 15. It leads to the constraints that has been mentioned in the problem. The major objective is to find out the optimum sequence. It is to be processed and starting and finishing time of various jobs through all the machines. Moving on with respect to the no passing rule, that is to be applied on the previously discussed schedules, that is M1, 2, 3, and 4, considering four different jobs need to be performed on a machinery. So no passing rule here implies that passing is not allowed to that particular machine. And that is, same order of jobs is maintained over the each machine. If there is any changes within the dimensional accuracies need to be performed on that particular machinery, for the convenience of machining conditions, the tool bits and tool conditions or positioning of the work part need to be changed. So for each n jobs, indeed to process m through m machineries in order of the sequence as specified before, that from machinery 1 to 2 and 2 to 3 and simultaneously from 3 to 4. If this rule will mean that each job will go to a machinery 1 first and 2 next and lastly to the M4 after crossing this M3. This is a static process which will continue, we'll be calling it a cyclic process also. Even there will not be any changes required in such a cases. If all the jobs arrive simultaneously, there is dynamic arrival pattern will be followed, where the jobs are arrive continuously in the flow chart, and that too will be characterized based upon the demand from the different places. And here need to be followed different assumptions here under these sequencing problems. First one, it is no machine can process more than one job at a time. That is nothing but after completing the job in the M1, then it will be object or thing will be moved on to the machinery 2, and later on another one of the input material will be entering into the machinery 1. Hence, single machinery cannot perform the task on two different workpieces. That's the first condition. Next one, the processing time on different machines are independent of the order in which they are processed. I think but time basis, it will be independent depending upon the machineries, because the task as per the given dimensions it will be getting varied. And beyond this, if you have been considered some ideally considering machines as per the time basis should be existed in between one machinery to the another machinery, and even the time involved in moving a job from one machine to the another is negligibly small. And that time which is acting as just we have been discussed between one machinery to the another machinery, it is very much small, that is almost in between 1 to 2 minutes of time, or else if it is in seconds of time, it's very much negligible. So each job once started on the machine is to be performed up to the completion on the machine. Even the single object need to be manufactured as per the required criteria, or that is program. It has to be processed on that particular machine. And even all the machines are of different types. Even for processing single object on single object, almost all the machineries need to be operated. And even all the jobs are completely known and ready for processing. Hence, a job is processed as soon as possible only on the order specified. Because ideally, if there is no any demand, hence the machineries will not be switched on, because of the dead stock will be maintained, and even the economical factors also implies more in the case of storage. Hence, these are the assumptions which are sequenced in a problem. Otherwise, the complicancy may be arise. Nothing but the economical criteria and time factors overall will be getting disturbed. Here, moving on with respect to the criteria as we have been discussed it, processing of n number of jobs through two machines, three machines, or else a single machine. In the single machine we have been discussed previously, and simultaneously here two different machines considering machinery A and machinery B, and it has to be processed after completing the certain task in the machinery A, and have to process towards the machinery B. Here place an basic steps, small processing. The time that is being processed in the case of machinery A or B, if there is any tie select either in the smallest processing time, nothing but it will be almost similar in need to operate with respect to the given time schedule in between step, that is machinery A and machinery B. The smallest time is on the machinery A, and then place it at the first place of the machinery B, and with correspond to the job that is shifting from the machinery A to the machinery B, this is called cross of that job. And if there is any tie for minimum time on both the machines, then we'll be selecting the machine A first and machine B at the last, because after completing of the task within the machinery A only, then it has to be moved on to the machinery B. Hence, these are the criteria of processing. And if that process is repeating in n number of work parts, then repeating of these step 2 and 3 to reduce the set of processing times, that it will complete the overall tasks that has been given in the form of a program which corresponds to the jobs already assigned. And after finding this, the optimum sequence we can find the following characterizations, that is total elapsed time and ideal time in a particular machinery. Right here, the total elapsed time is equal to the total time between starting of the first job of the optimum sequence on machinery A and completing the last job on the machinery B. And here, ideal time in the machinery A, that is time when the last job in the optimum sequence, and previously in between one work part to another work part, commonly the work parts are being moved on within the machinery, and these will drive the entire machineries to be worked in the A segment and will be moving on to the B segment. And hence, this time when last job in the optimum sequence is completed on the machinery B minus machinery A. Here we will be having a small problem. Yes, considering in a factory there are 6 jobs. So here specified in the tabular column 1, 2, 3, 4, 5, and 6. So 6 jobs we are having. For each and every process to be processed, in which it should go to a machinery A and machinery B in order A and B. Initially, it has to take place in that first job. It has to place in the machinery A, and later on it has to move to the machinery B. And the process timings in minutes are given. So for the first processing time in the machinery A in the job 1 is 7 minutes, and later on after completing this 7 minutes need to be moved on to the third 3 minutes to be processed in the second machinery. So hence, so when this 3 minutes need to be progressed in the machinery B, simultaneously we will be calculating the lapse time, that is total lapse time, that is B minus ideal time to be remained in the machinery A, that is B minus A. We have been already discussed that 3 and minus 4 is the factor. So 4 minutes machinery A should be in an ideal mode until the operational process that is being commenced in the machinery B, or else vice versa. If the task has been reversed, vice versa. Nothing but after passing the object from machinery A to the machinery B, firstly, within 3 minutes, the machinery B will be completing the task. So second part which enters into the machinery A will perform the task in 7 minutes, but only machinery B completes in 3 minutes. So indeed, to compensate this 4 minutes of time, this machinery B should be in an ideal mode for the second workpiece until the task need to be performed or completed in the machinery A. Right? That is the ideal mode of staying this machinery B until the process that is being commenced in the machinery A for the second object. And after completing that, it will be arriving into the machinery B. After entering the work part from the machinery A to B, simultaneously another work part will be loaded to the machinery A, and this take 3 minutes of time. This makes 3 minutes of time. After 3 minutes, machinery B will be completing this task, and but machinery A need to be performed 7 minutes of activity. So additionally 4 minutes from the machinery B. So it has machinery B need to be stay off for further 4 more minutes in an ideal mode. So that is the major strategy here. Here almost we have been given ideal time need to be maintained. So for machinery B in the given problem, 4 more minutes in the sequence of characterization or manufacturing need to be identified. So here the main constraint has been given that indeed to calculate the optimal sequencing and total lapse of time, considering for all that sigma, for all the jobs we need to find out the total segment time. All right. So these need to be identified. So we'll be having a detailed look here. First one, first one, the least of all the times given in the job 6 in a machinery B. So what is the least time given the job number 6? There is 1 in the machinery B. That is the first step. So for performed job 6, it is a N, and that will be titled as an end one. And second one, of the remaining timings, now minimum is job 3 and occupying the sequence characterizations. So it is characterized on the minimum on the machinery A. And first one, least criteria of operational C in the consideration of B machine, that is 6 as per the criteria we will be seeing. For the least time that is occupying in the machinery B, that is 1 minute of time, and that is also in sixth job. So that plays a major important role here. And simultaneously, the remaining timings, the minimum is for job 3 on machinery A, that need to be allocated first in the job 3, right? So here job 3, and from the machinery A, it occupies only 2 minutes of time, and later on almost all the jobs are increasing in strategy. So it has been scheduled here. And step 3, as per our discussion, now the smallest time is 3 minutes for the job first on the machinery B, and thus performs it job 1 at the second last before. Simultaneously, in the B, which is occupying first, will be allocated here in the first job. Second least, so second least here is 1, and later on in the first job it occupies only 3 minutes B, so least one. In such a way we will be calculating again for A, second one we will be taking here too. So in such a way, the overall table or column will be filling for 6 different jobs. So after completing it, we'll be placing a tenure difference as per the total lapse time need to be collected. So considering the machinery A, the sequence of jobs, that is 2 minutes, 4, 5, 9, 7, and 8, vice versa, as per the table or column framed just now, that will be taking place here. And machinery A input time and output time, machinery B simultaneously the input time and the output time. And what is the ideal time that has been existing in between this strategy need to be found out, that is output time to the machinery B. And in such a way, the overall time lapsed will be identified, as we have been having a formula here, total lapsed time. The total time between starting the first job of optimum sequence of machinery A and the completing of last job on the machinery B. So as per our criteria, we have been scheduled the first B type, which will be having the least priority of job, and A machinery, which is having the least priority of the time first, and that has been scheduled in our machineries, and the corresponding timings has been noted until the completion of the task in the machinery A, and material which is being entering into the material A for the operational process, and after 2 minutes it is being served out. Simultaneously, after 2 minutes it is entering into the B, and after commencing of 6 minutes it is being entering into the uh, uh, finishing process. So what is the ideal mode? Ideal mode. So that need to be identified. So 6 overall consideration, it is maximum criteria 2 minutes, 2 minutes, 4 minutes, and machinery A corresponding to a work of 2 minutes. So hence it is having 6 minutes of time, and based upon this 6 minutes, ultimately for completing both the tasks in machinery A and machinery B, it takes 8 minutes of time. So 8 minus 6, that is 2. So 2 is the ideal time need to be wait for the by the machinery B to be commenced or to enter the object which is already completed the machining process in the from the A. Hence, 2 minutes ideal time need to be spent here by the machinery A, because the time which need to be performed the task in the machinery A is very much high when compared to the machinery B. Right? Okay. Next one. Vice versa. Simultaneously, 4 minutes of time will be taken in the case of machinery A, and machinery B it is 4. So splitting in the category characterizations 2 and 6. The mean difference it is 4, correspondingly satisfied, and machinery B 8, and here this is 16 and 8. 8 the mean difference it has been from the machinery, it has been satisfied, and hence there is no any waiting time period for the commencement, because after completing the task by the machinery A, immediately it will be entering into the machinery B. So there is no any waiting time period. So in such a way, we'll be calculating for each and every specific job, right? So this is the criteria we'll be following in the case of our finding this total lapse time. Simultaneously, we need to find the total ideal time that has been existing for the machinery A is a minute, that is 36 minus 35, and for machinery B this is the time period, as we'll be obtaining this values from this criteria 2 plus 1 plus 5 for the machinery A, 2 plus 1 plus 5, 8 minutes, and here we'll be having only 1 minute because of this 36 minus of 35, 35. So 36 basically minus 35, so only 1 minute of waiting time. Clear? Okay, we'll be meeting in the next class. Thank you.